How does Techmatic deal with abrasive materials wearing through bends and piping? What's the solution to that?
Okay, I think we found. Yeah, thanks, Steve. I think we've found a pretty novel solution for that, and people always say ceramic line bends, and the first thing is put the ceramics on the inside of the bend. And purely by chance, we've actually gotten to a point where we now actually line our bends on the outside. And the theory behind it is we effectively had a problem on site where we had bends wearing through in 2-3 weeks. And they had wear back bends on them, which is typically a channel that you weld to the back of the bend, and you allow it to wear through, and then assume that the material fills that void, and then it wears against itself. But even those wear back bends were wearing through. So in pure desperation, we glued ceramic tiles onto their holes on the outside of the bend. We found that these bends started lasting, another week, 2 weeks, 3 weeks. And we then had to look, well, that is a possibility that we've actually got something here. And the other problem that you have with wear back bends is often that once it's worn through the back of the bend, it actually then deflects back towards the inside of the bend and then starts wearing through there. So you get wear patterns on this bend that literally wears through everywhere, and you can't put a wear back on a complete bend. And then you start looking at putting ceramic tiles inside bends, and that's a problem on its own because you just don't have the access, especially if we're looking at 65 nominal bore, 100 nominal bore pipes. So we've developed a bend now that we actually put a ceramic, it's an epoxy coated ceramic on the outside of the bend, a 12 mil coating. And that effectively we allow the pipe to wear through at the points where it impinges on the pipe itself. Now, because the conveying pressures aren't that high, it's not a major issue. The actual ceramic can contain the pressure. But as soon as it's worn through the bend, it starts wearing against the ceramic. And these bends, we've had them now, some of them last for 36 months. So that's how we deal with it on the lean phase side. We don't always do it because, those bends are expensive in the end. But where we have a material, low conveying rate, where we can't implement a dense phase just purely because of the cost, and if it is an abrasive material, we do use these ceramic coated bends.
Maybe, Karsten, to add on to that, you kind of answered it. My first comment on that would be just to go slower. I mean, my passion is dense phase, and I will say I like to press the envelope of how slow can you go. But obviously, there's a point of, yes, you've gone that slow, but now there's no, let's say, contingencies in the system. Maybe there's a valve leaking or a gasket blew out. You can't have a system that's that dependent on that finicky that if something happens, it stops conveying or it just blocks. But yeah, the first one is just to go slower. But there is various bend technologies out there. Personally, I'm a big fan of white iron bends. Just because I've seen on construction sites what really happens to those tiled bends. Say, for instance, you have a project up in Zambia or the DRC, and these days, even if you go to Mpumalanga, it's that bends are going on a truck, and by the time it hits site, it bounced around on a truck, and it's actually getting damaged. So now you have a bend that's tiled, but it's actually jeopardized where a month into it, the tile starts coming loose. So it's not really the tiles that's wrong. It's just because the bend got damaged, or they drop it when they offload it, or they bump it when they try and install it. So for that reason, I tend to prefer to use white iron bends. The disadvantage is the moment you put some leverage on the flanges, you just break them, and now you need to replace a bend that's very expensive. Other ways that we've also used quite successfully is just to use a normal elephant hose or a rubber hose in the bend. And obviously that flexes with your material. That's also a good indication of how the material really goes through your bend. But it's generally quicker to install, but just the rubber or the nature of rubber or the advantage of rubber assists in combating that wear that you normally find in bends. Another way is just, if possible, is to slow your material down through bends. But the more you do it, the bigger your back pressure becomes, and at some point you're just unable to do it with a fan or a blower anymore. So that is most probably the single biggest factor that we do consider when sizing these systems.